Okay, so we have two sections on specific types of sequences and then also series. This one is called arithmetic. It is spelled arithmetic. It is pronounced arithmetic. So arithmetic's a noun, arithmetic is an adjective. And arithmetic means that you're just adding the same number each time. So if I have a sequence that goes, say, 2, 5, 8, 11, 14, 17, then the apparent pattern is that you're adding 3 each time. 5 minus 2 equals 8 minus 5 equals 11 minus 8, and so forth. And whatever this number is called the common difference. Difference goes from one to the previous one. So if I take any term in the sequence and I subtract the guy before, then I get the common difference, and we call it D. This will just be a sub 1 still. So if you know a sub 1 and you know D, then you know everything in this case. There are two ways that you can define an arithmetic sequence. One, you can just say a sub 1 is 2, for example, and then a sub n is always step back 1 and add the common difference. So in this case, a sub n is a sub n minus 1 plus 3. So I guess if I want to write that kind of clearly, I would say those two things only. So a sub 1 is 2, a sub n is a sub n minus 1 plus 3. And that gives you everything. From a sub 1, you can get a sub 2. From a sub 2, you can get a sub 3, and so forth. An arithmetic sequence can also be defined explicitly, because in this case, a sub n, we would have taken 2, and we would have added 3 some number of times. You might just want to put an n there, but when you do that, then a sub 1 becomes 5. So the way it went was 2, 5, 8, 11, 14, 17. Sorry about that, I will silence that. And so forth. So you have 2, this a sub 1, you have not added 3 yet at all. For a sub 2, we've added 3 once. For a sub 3, we've added it twice. So we've always added it n minus 1 times. Once I've done that, I could just distribute that 3 as well. So that this would be 2 plus 3n minus 3 equals negative 1 plus 3n. And then you can see it's linear. So if it's linear, then it's arithmetic. If it's arithmetic, it's linear. But we generally speaking either say a sub 1 is whatever a sub 1 is, a sub n is a sub n minus 1 plus d, or we say a sub n is, we take a sub 1 and we add d n minus 1 times. So these are the two patterns, the top one being recursive and the lower one being explicit. Okay, so we want to decide if this is arithmetic, and if so, what is the common difference? So all we do is find the difference between the terms. 224 minus 213 is 11. 235 minus 224 is 11. 246 minus 235 is 11. Because these are all the same, then yes, it's arithmetic, and the common difference is 11. We want to write the first 5 terms of this one. The first one is for free. And then we're going to add a negative 2. So subtract 2, subtract 2, subtract 2, subtract 2. The number of people employed at a particular industry in 2000 and 2010 are given this way. Suppose that the number of employees rose linearly from 2000 to 2010. So remember, linearly is arithmetic. So if it's just integer entries, like these years are integer, then linearly and arithmetic are the same. So n equals 0 represents the year 2000, and we want a formula for the nth term. So a sub 0, instead of a sub 1, we're starting with a sub 0. Okay, so it rose linearly from 2000 to 2010. From 2000 to 2010, it increased 10 times. It increased for 2001, for 2002, for 2003, and so forth. So the total rise, the slope, to find the slope, you take the total rise over the total run, and we get, let's see, 489, 151. So 64. The slope, also known as the common difference, is 64. So we want a formula for the nth term. This time, in a sub 1, we've already added 64 once, because a sub 0 is 2511. So a sub n equals, you take 2511 and you add 64 n times. So again, normally it's n minus 1 because we have a sub 0 running around instead of starting with a sub 1. It's slightly different. And we want to estimate the number employed in 2008. So that's 8 years after 2000, so a sub 8. So 3023 would be our guess for that. Okay, so arithmetic sequences are as described. An arithmetic series is where you take the sum of the sequences. So if I take, say, I equals 1 to n of a sub I, this is also called S sub n. That's the partial sum of the first n numbers, first n terms. So if I take the one we had before, for example, I could take S sub, say, 6, the sum I equals 1 to 6 of a sub I would be 2 plus 5 plus 8 plus 11 plus 14 plus 17, like that. Now, let me tell you a little story. There was a mathematician named Gauss who was actually sort of a terrible person, but a brilliant mathematician. And when the story goes that when he was in elementary school, his teacher was going crazy like you would if you taught elementary school, and just wanted them to all be quiet and gave them the assignment to add up all the numbers from 1 to 100. Of course, if you take all the numbers in sequence, 1 to 100, let me get this for a second. Whoa, did not mean to do that. I'll just clear it all. This 1, 2, 3, 4, that's arithmetic, where the common difference is 1. But little gal, so the story goes, recognized a pattern. These two make 101. These two make 101. These two make 101. Lo and behold, you have 50 pairs, each of which makes 101. And little tiny Gauss was finished and ruined the teacher's day, presumably by noting that this just adds up with pairs like this. Similarly, any arithmetic sequence, so if we take 2 plus 5 plus 8 plus 11 plus 14 plus 17, these make 19, these make 19, and these make 19. So I have 3 pairs of 19. This 3 came from the fact that I've got 6 numbers and divided it in half. Okay, but, so presumably you can see then, if you have an even number, that you have n over 2 pairs of a sub 1 plus a sub n. But suppose you have an odd number. Then let me just drop one of those. Okay, so then you have 2 pairs still that match, in this case 16. So you have, if you drop out the guy in the middle, there are n minus 1 over 2 pairs that make a sub 1 plus a sub n, the first and the last. You also have this guy in the middle, but the guy in the middle is always the average of the outside 2, a1 plus an over 2, because it's right in the middle. If I therefore factor out a sub 1 plus a sub n, I get n minus 1 over 2 plus 1 over 2. So it's the same. So the sum is always n over 2, first term plus last term. This is, remember, for arithmetic. So your first question here would be, is this arithmetic? And we're subtracting 0.6, we're subtracting 0.6, we're subtracting 0.6. You would do it like this, 5.4 minus 6, 4.8 minus 5.4, and so forth. And find that the common difference is negative 0.6. So we know it's arithmetic. So to find this partial sum, we would need to have n over 2, a1 plus an. The way this has been given to me here, I have a1 and I have an. What I don't know is how many terms there are there. So negative 34.2 equals 6 plus negative 0.6 n minus 1 times. So remember that from before, a sub 1 plus d times n minus 1. So I'm going to subtract 6 from both sides. Negative 40.2 equals negative 0.6 n minus 1 times. Dividing by negative 0.6, we would get 67. I think. I guess I'll check. Yeah. So that means 68 is in. How did that happen? Well, I suppose you can see it okay. So S sub 68 is 68 over 2, 6 plus negative 34.2. Actually, I don't think you can read that very well. So. This equals 34 times negative 28.2 So there is the sum. This you will need memorized. Although I guess you can do the partial sum on the calculator actually. Once we've written it already in terms of D and N, then we could have gone to math, sum, operations, sequence, and then put in 6 plus, if you want, you could do a minus there, negative 0.6 times x minus 1 start with 1, end with 68. And there's our negative 958.8, which is hopefully what I had before. Okay, so this one could also be done on the calculator. I think this one is not so terrible to do by hand though. We're subtracting 6 each time. So negative 78 equals negative 6 minus 6 in minus 1 times. So we have 13 is in. So the partial sum for 13, that's 13 over 2 times negative 6 minus 78. I'm going to divide the 84 by 2 this time. So I get negative 42 times 13. So I believe this is negative 546. This probably wasn't the fastest way to do this. Let me clear this. It's probably good to practice these steps anyway. Okay. We want the first 50 positive integers that are exactly divisible by 4, which means 4 plus 8 plus and so forth. N is 50. A sub 1 is 4. A sub 50 is 4 plus, we've added 4, 50 minus 1 times. So 4 and 200 are our two n's. In this case, I could have divided this by 25 and added this. I thought those would be more difficult to multiply since I'm kind of doing it in my head here. So that's the only reason I divided the 2 through this one instead. If you had read this and realized it's always just going to be 4x, 4n, then that would have been fine too. Okay, we want the nth term of the arithmetic sequence, whose nth partial sum is this. So now we're just going backward. I say just. I realize going backward is somewhat mathematically traumatic, but so we know that S sub n is 3n squared plus 6n, but it's also n over 2 times a1 plus an. We can divide through by n, so that 3n plus 6 equals a sub 1 plus a sub n times 1/2. I guess I should have written the 1/2 over here. It comes from the n over 2. I'm going to multiply through by 2. Okay, but, so let me copy this. A sub n is a sub 1 plus d times n minus 1. So a sub 1 plus a sub 1 plus d times n minus 1, in this case equals 6n plus 12. That means then, well, let me go ahead. So 2 times a sub 1 plus dn minus d is 6n plus 12. This is the only part that's got n in it, so d is 6. So now I can say 6n plus 12 equals 2 times a sub 1 plus 6n minus 6. 2a sub 1 minus 6 is 12. 18 is 2a sub 1. 9 is a sub 1. So the arithmetic sequence is that a sub 1 is 9 and d is 6. There were several steps in it, but really at any stage there was only one thing that we could do because we didn't have any more information. Okay, and that is it for this section.